Everyone, myself Padala Rajashekar, Assistant Professor, Department of Civil Engineering, SR University Warangal, and today I am going to discuss second second presentation on irrigation engineering, particularly in that soil water plant relation. So this is the second tutorial, soil water plant relationship we will discuss and we will see. So water requirement of a crop. That means what are the required things? Like every crop requires a certain quantity of water after a certain fixed interval throughout its period of growth. That means it's like hydrology. We can see perennial, non-perennial, perennial rivers. Perennial rivers means water will be there for throughout the year. In the similar way, every crop requires some amount of water in terms of intervals. So that means fixed intervals. That means fixed interval. For example, if the certain crop X crop is here, it need 120 days. For example, so every 20 days we have to provide water to a particular plant. That means every 20 days interval we have to give that water until it reaches 120 days maximum. That means this is a water requirement for a crop. Water after a fixed interval throughout its period of the growth. Now, if the natural rain is sufficient, timely, no irrigation water is required. But in a tropical country like India, the natural rainfall is either insufficient or uneven as required by the crops. That means what here we are defining means this is India is purely depending on southwest monsoons 80%. So that means it will be only for 4 months, 3 to 4 months the rainfall. So here like India, the rainfall is like insufficient. We are telling that means entire India we can consider like there we can see drought regions, flood regions. So it was not evenly distributed in a good way like rainfall, which requires the crop to grow for 120 days or 150 days, whatever it may be. In regions such as this, artificial supply of water is ensured by irrigation. That means if we are constructing a dams, then we can supply reservoirs, the kind of barrages, weirs, or any kind of things. Then we can supply the water to the surrounding areas. For example, you can take this is a river, and if you are constructing here one barrage, so this portion and this portion we can irrigate through canal system. That means this is a one kind of that artificially supplying water to particular irrigation things. And the total quantity and the way in which a crop requires water from the time it is sown to the time it harvested is known as water requirement. That means from first day of the thing to the last day of the harvesting is called water requirement crop. Now you people can understand what is this. Different crops will have different water requirements, and it is the objective of the irrigation system to meet the water requirements of target crops command area. That means as I mentioned previously, one certain crop is having 120 days, X crop. In a Y crop is having 150 days, Z crop is having only 80 days. But we have to be ensure that this should this whatever it may be 150 or 80 or 120, whatever the things, supply should be uniform, like it should be perennial way. Perennial means throughout the period of that particular crop we have to meet. That is in terms of irrigation things, irrigation system. Now soil water classification. So this is a soil water classification. Water presence in the soil may be classified under three heads: hygroscopic water, capillary water, gravitational water. Hopefully these three can be explained with respect to the image. Here I am showing the right side. So this is saturated runoff above ground level. This is like a gravitational water plant unavailable. Capillary water plants are available, and hygroscopic water plant unavailable, because plant means the crop what we are taking. And the thing this comes under first, this up to here it comes under X is water unavailable, and available water, unavailable water. That means only the available water is now the field capacity. That means in shortcut we can call it as FC. The field capacity, that is 100 percentage available. Wilting point means permanent wilting point, like kind of things will be there, that is 0 percentage available. That means from here to here the water is available for plant, like through capillary water. This is oven dry, nothing will be there here. So now this is only the available water. Now soil classification. Now I just told hygroscopic, capillary, gravity, and these things. Now we want to see about gravity for instance. So that part in the axis of hydroscopic and capillary which will move out of the soil if drainage is provided. So now hygroscopic means when an oven dried sample is kept open in the atmosphere, this is known as hygroscopic water, and it is not capable of movement by the gravity or the capillary water. Here hygroscopic water which is unavailable completely they are telling. And capillary water is excess of hygroscopic water in existing in the pore spaces. That means here whatever the thing I am telling available water, this will be in the spaces of pore spaces of soil. Okay, pore spaces of soil if favorable drainage is provided. Water may also be classified as unavailable, available, surfluous respectively. Now next, soil moisture constants. Saturation capacity. The amount of water required to fill all the pore spaces between soil particles by replacing all air held in pore spaces, also called as maximum moisture holding. Here we can see water distribution, like saturation capacity. Field capacity means, as I discussed previously, it is a moisture content of the soil after free drainage has removed most of the gravity water. It can be referred to as amount of water available in the soil for the plant use. Wilting means bottom. There will be temporary wilting, ultimate wilting will be there. Here we can see this is a dry soil and this is the permanent. This is the available water. That is from here it will be 100 percentage. It will be 0 percentage. So field capacity, available water, no plant stress, available water, plant stress possible. Again, this was divided into two, excess or gravitational water, these things. So now soil moisture contents, in that particularly temporary or ultimate wilting, we can see at the permanent wilting point. This is very important. Permanent wilting point, the films of water around the soil particles are held so tightly that the plant roots cannot extract enough moisture at sufficient rate to satisfy transpiration requirements of the plant, resulting in wilting of the plant. Now you understood that they cannot extract, in a simple sense, plants roots cannot extract enough moisture. And however, plant will regain its strength if water is added to the soil. Now temporary wilting point is, it may sometimes takes place during the hot windy day, but the plant will recover in the cooler portion of the day. No addition of water is required. So you people can understand easily what is it. And ultimate wilting means, when ultimate wilting occurs, the plant will not regain its health even after addition of sufficient water. That is ultimately, and to the soil, and the plant will die. So this is very ultimate means there won't be any kind of scope, but temporary wilting means some scope is there for the plant to recover. Next, soil moisture constants. In that particularly saturation, field capacity, wilting point. Now we can see all pores are full of water, gravity water is lost. Here we can see all pores is there and gravity water is lost. Field capacity, available water for plant growth. Inside we can see the availability of water is possible. But a wilting point, no water. There won't be very small drops will be there that we cannot extract. Plants cannot extract. So here it will be good and here it is not good, and here it is like a gravitational water is lost. And here we can see the full of layer soil at saturation capacity moisture. For example, if you are taking this circle and fill it with some dots and with respect to water, that it means full completely. And after draining out a gravitational water, soil at field capacity. This is the situation of the field capacity after taking the gravity. And this after extraction of the available water from the plants. Available water from the plants. This is gravity, and this will be the hygroscopic is this portion. That means we can understand here in a way. This is gravity. This is hygroscopic. This is capillary water available after drying in oven moisture for 10-0%. Classification of the soil. Either we can get some aware of these things or this thing, both are the same thing they are representing, and this will be an easy way of telling that this will be the final one: hygroscopic, gravitational, and a capillary water. Now soil moisture contents available moisture. The difference in water content of the soil between field capacity and permanent wilting point is not available. As I mentioned, we can see here permanent wilting point is a field capacity. This is the only where we can take available water is there. That is, available water is nothing but the difference between field capacity and permanent wilting point. That's it. So readily available moisture means this is another kind of thing. It is that the portion of the available moisture that is almost easily extracted by plants is approximately 75%. That means readily available moisture is nothing but 75% of this thing. That means 75% of available moisture. So now you people can understand, there won't be any kind of confusion, right? Available moisture means simple, permanent wilting point and a field capacity. Readily available moisture means it's a 75% of available moisture. It's as simple as that. Now soil moisture constants expressed in depth units. Like expressing soil moisture constants in depth units help us in calculating the depth that is required to be provided for healthy yield of crops. That means here we can some representations are there. D means root zone depth, capital D. Small d means depth of water at the crop, and gamma S means specific weight of soil. Gamma W means specific weight of water. Now field capacity. Available moisture means field capacity minus permanent wilting, that we know. Just now we have learned, and readily available means 75% of available water. Now field capacity means gamma W by gamma W small d by gamma S into capital D. Depth of water held by soil at the field capacity is, then if you want to do gamma W, gamma S by gamma W, that means soil by water into D, capital D into field capacity. That means depth of water held by soil. Depth of water held by permanent wilting point. Now we gone through field capacity. Now permanent, because available water is at field capacity and a permanent wilting point. That's what we have seen previously, right? For field capacity, gamma S by gamma W into D into FC. For permanent wilting point, gamma S by gamma W into D. These two are common terminologies for both and into permanent wilting point. Now depth of available to plants is, now actually how much depth of available plants is, as we can see from here to here, field capacity to permanent wilting point, water is available. Now overall formula is, this way we can remember easily, gamma S by gamma W, that is specific weight of soil by specific weight of water into capital D. That means root zone depth into field capacity minus permanent wilting point. Now depth of water available to plants per meter depth of soil. That means per meter depth of soil means now we can directly eliminate this root zone depth. That is equal to gamma S by gamma W into FC by gamma S by gamma W into FC minus PWP. So this way we have to learn the, from concept we have to learn the equations, then we can remember. If you are unable to, if you are not able to recall, we can get back from concepts, formulas. Now, importance of soil moisture constants. That is why we have to learn what is the importance in the soil moisture constant. Soil moisture constant means we know that. Now, it is essential to maintain readily available water in the soil if plants are given optimum yield. And it should be noted that the plant growth may be retarded if the soil moisture is either deficient or excessive. The optimum moisture percentage is thus that moisture corresponding to which optimum growth of the plant take place. That means here you see the optimum growth is here, and this is y-axis indicates rate of growth and x-axis indicates moisture content. Now you can see wilting here, wilting coefficient there. From here this curve is going like that. That means this one is readily available moisture, that is 75 percentage of available. In that we can see optimum water, that is optimum growth. The optimum moisture percentage is thus that moisture corresponding to which optimum growth of plant take place. That's what here they mention. As shown in plot between moisture content, that means x-axis of the soil, and rate of growth, that is y-axis. At any time, the moisture content in the soil should be between field capacity and the lower limit. Should be between field capacity and the lower limit. That means always if we are maintaining this thing, that means 75 percentage of the available things, readily available moisture, it will be good. Thus, M naught is a maximum level up to which the soil moisture may be allowed to depleted in the root zone without fall in the yield. That means if you are maintaining that thing up to there, readily available moisture, there won't be any kind of fall in terms of yield, and the production, food production will be good. Now, importance of soil moisture constants. Now we can see here water requirement for plant. Here a typical rainfall sequence, a plant growth sequence, and a supplement irrigation. Now, if you are seeing initially, there is no rainfall, and plant growth is in initial criteria, and water requirement is this much, and we have supplement this much. Okay. Next, here also the same scenario we have given, but here sufficient rainfall is there for that particular plant to grow. Again, supplementing the water is not required at this stage. So sufficient water is there. Now here, there is no rainfall, so we have to give, and we have provided here. Then scanty rainfall, but there is a rainfall, but it is very less rainfall, so we have to supply accordingly. See here, we can see the difference. Already rainfall is there, but less rainfall, but we have supplied. Now again sufficient rainfall is there in that particular seasons. Up to here we have given, and at the end of the, like it's a last stage, like harvesting stage, we can supply very less. So here we can supply it in the less way. This is a way, accordingly water requirement you can see this much is sufficient, this much we done. So according to the rainfall at that particular location, and if we are sending, we cannot send like that simply. We have to see the situation of the rainfall, and we have to measure and how much, whether it is sufficient or not. According to that, whether it is scanty rainfall, that means low rainfall, or sufficient rainfall or insufficient rainfall. According, if there is no rainfall, according to rainfall and water requirement for the plant, according to this thing, and we have to supply the water throughout the period of that particular plant. Now, importance of soil moisture constants. Now here we can see soil moisture content, here field capacity, and lower limit of readily available, the thing is there. So accordingly, first how much it can be taken like that, and it is increased, and like that we can see according to the supply, according to the growth we can make. Now importance of soil moisture contents continued, like the thing, when water is done, the amount of water supplied should be such that the water content is equal to the field capacity. water will be gradually utilized conceptually by the plants after the water application and the soil moisture starts falling. Now we can see here volume of water in terms of percentage, and according to the sand, according to the soil, sorry, sand, sandy loam, silty loam, clayey loam, clay. So available water, like total water, upper limit and a lower limit, unavailable water. When the water content in the soil reaches the value of m naught, that means already previously discussed, it should be m naught and field capacity for readily available water, and fresh water doses water is to be done so that the water content is again released to the field capacity of the soil. It's kind of a thing that what is the plant and how much water is required. For this particular plant, how much water is required. That's the way in engineering aspect we have to give to the plants for their good growth. Now there are two terminologies, one is duty and another one is delta. So these two are the very important things. Duty represents the irrigating capacity of a unit of water. It is a relation between the area of crop and the quantity of irrigation water required during the entire period of the growth of that crop. It is denoted by symbol D. For example, if 3 cubics of water supply is required for crop sown in an area 5100 hectares, the duty of irrigation water will be 5100 by 3, that is 1700 hectares per cubics. And then the discharge of the 3 cubics will be required throughout the base period. That's the way we have to calculate. And delta is nothing but delta is the total depth of water required by the crop. Total depth of water required by the crop during the entire period that crop is in the field, and it is denoted by a symbol delta. Here also, for example, if crop requires about 12 waterings at an interval of 10 days, okay, and the water depth is 10 centimeters in every watering, for example, then the delta for that crop will be 12 into 12, that is 120 centimeters, that is 1.2 meters. And if the area under that crop is a hectare, then the total quantity will be 1.2 into a equal to 1.2 hectares meters in a period of 120 days. That means here duty and delta relation is nothing but, this is very important one, delta equal to 8.64 into B by T, where B is base period of a crop. This is very most important one. Delta equal to 8.64 into B by D. Other important terms, principal crops and crop seasons. Crops can be classified into following ways. That means, what are the crops? Means agriculture, based on crop season, based on irrigation requirements. Based on agriculture classification, field crops means wheat, rice, maize, barley, oats, millets, grams, pulses. And we know that commercial crops are like sugarcane, cotton, tobacco, mirchi. And oil seeds crops, mustard, groundnut, sesame and soya. Horticulture crops like various fruits, vegetable crops and flower crops. And plantation crops means tea, coffee, coconut and rubber. And forage crops means fodder grass. Miscellaneous means medicinal kind of things crops are there. That means based on the agriculture class, I told you agriculture classification based on the crop season, based on the irrigation requirements. That means field crops, that field crops are more like more depending, field crops and commercial crops we were depended more, like wheat, day to day life, like wheat, rice, maize, sugar cane, and oats, millets, grams, pulses. And this is also one of the things which were required, like various fruit crops, vegetable crops and flower crops. And this is also day to day things, plantation crops. Now based on crop and irrigation requirements, we'll see. So based on crop seasons, there are according to season we can go, like rabi season, that means winter, kharif season, that is monsoon, perennial crops, and 8-month crops. So now the thing is that rabi crops means winter crops. Crops are sown in winter from, like means, first kharif, rabi season means October to December crops, and harvested in summer April to June. That is rabi crops. And kharif crops is like that, like monsoon crops. Here kharif crops is like that, known as a wet summer. And here the crop are sown with the onset of southwest monsoon, that in June, July, and harvested in autumn, that is September to October. Perennial means these are crops that require water for irrigation throughout the year. This is very important. That means supply should be for throughout the year. Like sugarcane is a major one, fruits, vegetables. And 8 months crops is nothing but cotton. Requires irrigation water for 8 months. But the scenarios we can understand here: agriculture classification based on crop season, based on irrigation requirement. That means agriculture classification we have field, commercial, these all things. And based on crop season we can see rabi season, kharif season, that means winter crops, monsoon crops. According to the crop, according to the types, we have to supply the water to particular things. Now, crop period, base period, and these things we will see. Crop period is nothing but it is the time in days that a crop takes from the instant of its sowing to that of its harvesting. Crop period. Base period means where it refers to the whole period of cultivation from the time when irrigation water is first issued for preparation of the ground for planting the crop to its last watering before harvesting. And cross command area is nothing the total area layable between drainage boundaries which can be commanded or irrigated by the canal system. And cultivate command area is nothing but the gross command area also contains unfertile barren land, local ponds, villages, and the other areas such as habitations. Cultivate command area is very important. These are the known as unculturable areas. These areas are which are the crops can be sown, grown satisfactory with is known as culturable command area. In terms of irrigation, this is a percentage of culturable command area proposed to irrigate during either a crop season or a dry during a dry. Concept to use is the depth of water consumed by evaporation and transpiration during crop growth. Now, irrigation water quality. Functions of irrigation water quality, that means solvents for nutrients. The supply moisture essential for life of bacteria and chemicals action beneficial to plant growth. And salts present in the soil react to produce nourishing food products only in the presence of water. Cools the soil and creates favorable condition for healthy plant growth and washes out or dilutes salt in the soil. Good irrigation water is one of the performance which can above mentioned functions. Now, quality way, depending upon the types impurities present in water, some prominent ones are concentration of sediments, total concentration of soluble salts, proportion of sodium ions, concentration of toxic elements such as boron, concentration of bicarbonate, and bacterial concentration. Now, this irrigation water may be classified in the following, like it will be like total concentration of soluble salts, sodium concentration, electrical conductivity, total salts, and we call it as TDS, total salt content, and ESP, sodium concentration, and boron concentrations. Now, the classification based on total concentration of soluble salts, like water with high salinity is toxic to plants and possesses salinity hazard. High concentration of salt in the soil can result in physiological drought conditions. Water salinity is usually measured by TDS, that usually done total dissolved solids, or the EC, electric conductivity. The TDS is sometimes referred to the total salinity and is measured or expressed in ppm, that is parts per million. EC is actually measurement of electric currents. And here the classification based on total concentration of soluble salts, we can see the types. If it is low salinity water, medium salinity water, high salinity water, very high salinity water, what is a suitable irrigation for them? Then that is the range also there, 100 to 250, 250 to 750, 750 to 2250, and 750 to 2250 micro MOs per second, for centimeter, sorry. So if it is low salinity, suitable for all types of crops and all types of soils, it should be low. If it is medium, can be used if moderate amount of leaching occurs, normal salt tolerant plants can grow. And if it is high, unsuitable for soils with restricted drainage, only high salt tolerant plants can go. And if it is very high, nothing, we can't do anything, unsuitable for irrigation. Now, this is the one kind of thing as I discussed SAR, ESP, like that kind of things, sodium absorption ratio. Water contains a large amount of sodium of the is of special concern due to the sodium effects on the soil. Like it's a sodium hazard is usually expressed in terms of SAR or sodium absorption ratio. So now in terms of SAR, there is another one which have given this low, medium, high, very high. They have given some kind of things suitable for all and suitable for organic soils, and high means harmful for all types of soils. It's very high means completely unsuitable. That means here range also they have given 0 to 10, 10 to 18, 18 to 26, and above 26. And canal classifications. So these canals can be classified in the following ways, like based on nature of the source of supply. If there is a source of supply, one kind of canal, and a financial output, functioning of canal, boundary surface of the canal, and based on the discharge and relative importance given, and canal alignment. So if I want to give in a overview of canal classification, if there is a canal, for example, is divided into nature of the source, financial, function, boundary, discharge importance, canal alignment, as I discussed. So now nature of source means there will be permanent and indulgent. Already we discussed in the previous lecture what is permanent and what is indulgent. Financial means it should be productive canal and protective canal. These two are very important. And function means irrigation canal, carrier canal, feeder canal, navigation canal, and power canal. Function, the functioning of the things. It should be navigation and it should be power, feeder, carrier, indulgence. And boundary surface means aluminum canal, non-aluminum canal, rich boundary canals. Discharge and importance means main canal, branch canal, the things main canal, branch canal, and distributary, major distributary, minor distributary, and water courses. Coming to canal alignment, contour canal, watershed canal, side slope canals. This is the final classification of the canals. And thanks for watching.